In this video, I want to start to look at some of the basic properties of logarithms and give examples of using them. Before I do that, I'm going to review some basic properties of exponents. The first, b to the m times b to the n is equal to b to the m plus n. If I multiply two exponents with the same base, I can just add the exponents. The next one, b to the m over b to the n is equal to b to the m minus n. If I divide two exponents of the same base, I subtract the exponents. So the properties of logarithms I want to look at are the logarithmic equivalents to these two properties of exponents. The first one, log base b of mn is equal to log base b of m plus log base b of n. If I'm taking the log of a product, I can do the log of the first plus log of the second. As an example, log base 8 of 8x. This is a product, so I take log base 8 of the first part of the product plus log base 8 of the second part of the product. And in a previous video, I discussed that log base 8 of 8 is going to be equal to 1. Log base b of b, as long as these two numbers match, it's always going to be equal to 1. Plus log base 8 of x. The next example I look at, let's go the other way. Log base 6 of 4 plus log base 6 of 9. This time it looks like the right-hand side. I want to move it over. I'm adding two logarithms of the same base. It means I can take log base 6 of the product. 4 times 9 is 36. And if we think 6 to what power is equal to 36, we can figure out that this is equal to 2. Since this right here is the same thing as saying 6 to the x is equal to 36. We know that 6 squared is 36. So, once I combine these using this property, I was able to just get a single solution of 2. The next one, log base b of m over n is equal to log base b of m minus log base b of n. If I take a logarithm of a quotient, I can take the log of the top minus log of the bottom. As an example, log base 4 of 16 over x. Since this is a quotient, I would take log base 4 of the top minus log base 4 of the bottom. So this log base 4 of 16 means 4 to what power is equal to 16? Well, that's 2. So 2 minus log base 4 of x. So by separating them, I was able to simplify a little bit. Next, log base 7 of 7x minus log base 7 of x. So this time I'm going the other way. Since I'm subtracting these two logarithms, I can take the logarithm of the first over the second. Well, 7x over x is just 7, and log base 7 of 7 is 1. My next property, log base b of m to the p is equal to p log base b of m. If I'm raising this to an exponent, I can just move the exponent out front. As an example, log base 10 of x to the fourth. We bring the exponent out front. So this is 4 log base 10 of x. Another example, 1/2 ln of y. In this case, I want to go the other way. I want to bring the exponent up. So this is ln of y to the 1/2 power. And a 1/2 power is the square root, so I could also write this as ln of the square root of y.